The green schist facies includes the common product of low-grade metamorphism or dislocation metamorphism during medium to high-grade metamorphism that occur after geolite facies. During this type of metamorphism or during green schist facies metamorphism, the all sort of schist are formed like chlorite schist, biotite schist and garnet schist on the basis of different isogrades. The green schist facies is recognized by the abundance of green color minerals like chlorite, tremolite, chloritite, paraphyllite, etc., epidotes in peltic rocks, where the rock is richer in FeO and Al2O3 and poorer in K2O. The other important minerals are muscovite, fensite variety, biotite, almandine garnet, etc. in peltic rocks. The albite with anorthite percent less than 7 along with epidote is a characteristics of this facies. Furthermore, chlorite in presence of quartz and muscovite, chloritite, stepnomelane are the characteristics of this facies. The zones of these subfacies on the basis of presence of index minerals like chlorite, biotite, almandine garnet recognized by Barrovian zone of metamorphism, we can divide on the basis of these index mineral the green schist facies into three types. First is your chlorite zone and quartz, albite, muscovite, chlorite subfacies. Second is your biotite zone or quartz, albite, muscovite, biotite subfacies. And third is your almandine garnet or quartz, albite, muscovite, almandine subfacies. Mineral assemblages and metamorphic reaction in the different subfacies oblique zones. Chlorite zone or quartz, albite, muscovite, chlorite subfaces on the basis of ACF, AKF and AFM diagrams, we can identify the different mineral assemblages. Say for example, the ACF diagrams give the different assemblages like peltic, basic, calcareous and ultrabasic. Similarly, the AKF diagram, we can identify the peltic as well as quartzo-feldspathic assemblies, and with the help of AFM diagrams, we can recognize only the peltic assemblages. The peltic assemblages on the basis of ACF, AKF and AFM diagrams. First is chlorite, paraphyllite, muscovite, quartz, plus minus albite, plus minus epidote and paragonite. Second assemblage is your chlorite, chloritite, muscovite, fensitic variety, plus minus quartz, plus minus albite and plus minus epidote. Third is your chlorite, chloritite, paraphyllite, quartz, albite, epidote, and fourth is your chlorite, muscovite, quartz, albite, epidote, etc. quartzofelsitic rock. On the basis of AKF diagrams, we can find out the quartzofelsitic assemblies, that is the muscovite, microcline, chlorite, plus minus quartz, plus minus albite and epidote. Similarly, the chlorite, muscovite, stippleomelanin, quartz, etc. The basic assemblies, on the basis of ACF diagrams, we can find out the basic assemblies, and the basic assemblies is as epidote, tremolite, tectonite, chlorite, plus minus quartz. The calcareous assemblies is epidote, calcite, tremolite, tectonite, plus minus quartz. Or second is your calcite, tremolite, tectonite, plus minus quartz. The ultra basic assemblies is, on the basis of ACF diagrams, the assemblies is the tremolite, tectonite, chlorite, plus talc, plus minus quartz. Quartz, albite, muscovite, biotite subphases. The biotite zone is recognized by the first appearance of biotite in green schist facies. The biotite is formed by the following reaction. The muscovite plus chlorite give rise to biotite plus Al-rich chlorite plus quartz plus biotite plus water. Microcline plus chlorite give rise to biotite plus muscovite plus quartz. By the reaction 2, the chlorite is unstable in the presence of potash feldspar. Furthermore, stippleomelanin is unstable in this zone as it reacts with muscovite to form biotite and chlorite. By the reaction, stippleomelanin plus muscovite give rise to biotite plus chlorite plus quartz at 445 degrees centigrade 4 kilobar, 460 degrees centigrade 7 kilobar by Nice 1968. In aluminous peltic rocks, the pyrophyllite is disappear and kyanite appear at A corner. The pyrophyllite, by the reaction, the pyrophyllite give rise to kyanite plus water. This reaction was carried out by Carrick at 400 degrees centigrade 1 kilobar and 430 degrees centigrade 3.9 kilobar. Mineral assemblages on the basis of ACF, AKF and AFM diagrams. Look on the screen where we can observe the formation of two new minerals as compared to chlorite zone, that is the first appearance of kyanite and first appearance of biotite during biotite zone of green schist facies. The important mineral assemblages are as follows. The peltic rock assemblages are as follows: chlorite plus kyanite plus quartz plus minus albite, chloritite plus chlorite plus muscovite plus quartz plus minus albite plus minus epidote, chlorite plus muscovite plus quartz plus minus albite plus minus epidote, and last is your chlorite plus kyanite plus minus chloritite plus muscovite plus quartz, and muscovite, biotite, chlorite plus minus quartz plus minus albite and plus minus epidote. As per the AKF diagram, the important assemblies is your biotite muscovite schist, that is The main assemblage is your biotite, muscovite, chlorite, plus minus quartz, plus minus albite, etc. Whatever peltic assemblages we can recognize right from chlorite up to biotite zone, mainly phyllite or schist. If foliation is more, then schist. Quartzo-feldspathik assemblage, on the basis of AKF diagram, we can recognize the quartzo-feldspathik assemblage. The quartzo-feldspathik assemblage is as follows: the muscovite, biotite, microcline, plus minus quartz, plus minus albite, and plus minus epidote. The basic assemblage. The basic assemblage is recognized or identified on the basis of ACF diagram or with the help of ACF diagrams. Assemblage of basic is as follows: epidote, tremolite, actinolite, biotite, plus minus chlorite, plus minus quartz, plus minus albite, etc. The ultramafic assemblage, we can recognize or identify the ultramafic assemblage on the basis of ACF diagrams. Ultramafic assemblage is biotite oblique chlorite, talc, tremolite, actinolite, etc. Almandine zone or quartz, muscovite, albite, almandine garnet subfacies. The garnet zone of the green schist facies is recognized by the first appearance of almandine garnet by the following reactions: FeMg chloride plus quartz give rise to almandine plus Mg chloride plus water. Fe chloride plus muscovite plus quartz give rise to almandine garnet plus biotite plus minus aluminosilicates plus water. Mineral assemblages, on the basis of ACF, AKF and AFM diagrams, we can recognize the following mineral assemblages. The peltic assemblages are as follows: kyanite, chloritoid, chlorite, muscovite, quartz, plus minus albite, plus minus epidote. Chlorite, kyanite, muscovite, quartz, plus minus albite, plus minus epidote. Biotite plus chlorite plus muscovite plus quartz plus minus epidote plus minus albite. Almandine, garnet plus biotite plus chlorite plus muscovite plus minus quartz plus minus albite plus minus epidote. Quartzo-feldspathik rock. The quartzo-feldspathik rocks are recognized by AKF diagram, and the assemblage is the biotite, muscovite, microcline, plus minus quartz, plus minus albite, etc. The basic assemblage as per the ACF diagrams is hornblende, epidote, tremolite, actinolite, hornblende, albite, epidote, quartz. The calcareous assemblage: calcite, epidote, tremolite, actinolite and calcite, tremolite, actinolite plus minus quartz. The ultra basic assemblage is as follows: the tremolite, actinolite, almandine garnet, talc, etc. The lower temperature limit. The lower temperature limit during green cyst phases is recognized by the decomposition of pyrophyllite. The reactions are as follows. The kaolinite plus quartz give rise to pyrophyllite. The reaction was observed by Thomson in 1970 at 325 degrees centigrade 1 kilobar, 375 degrees centigrade 4 kilobar and 345 degrees centigrade 2 kilobar. Pyrophyllite give rise to kyanite plus quartz plus water. Reaction carried out by Carrick in 1968. The reaction observed at 400 degrees centigrade 1 kilobar and 430 degrees centigrade 3.9 kilobar. These reactions suggest for the beginning of green cyst phases, the temperature is around 400 degrees centigrade. The upper temperature limit. The upper temperature limit is recognized by the following reactions. The appearance of sterolite is the first reliable indicator for the upper temperature limit of green cyst phases and also the beginning of amphibolite phases. The sterolite is formed by the following reaction. Chloritoid plus kyanite give rise to sterolite. And second important reaction is chlorite plus muscovite give rise to sterolite plus biotite plus minus aluminosilicates. The investigation of these reactions by Hosek in 1967 and Richardson 1967 have yielded equilibrium temperature at approximately 550 degrees centigrade at 4 to 7 kilobar water pressure. Further, almandine is the common and important mineral in upper limit of green cyst phases. The garnet is formed by the breakdown of chlorite, FeMg chloride plus quartz give rise to almandine plus water. This reaction was carried out by Su 1968 at 552 degrees centigrade 3 kilobar, 542 degrees centigrade at 2 kilobar. The pressure condition during green cyst phases from chloride zone on the basis of appearance of kyanite, because the kyanite is stable only above 3.97 kilobar, that is close to 4 kilobar, because kyanite is your high pressure mineral. Therefore, on the basis of aluminosilicate triple point given by Holdway 1971, that is 501 degrees centigrade 3.76 kilobar. So, on the basis of triple point, we can say the beginning of green cyst phases pressure is around 4 kilobar. The upper pressure limit we can decide on the basis of breakdown of albite into jadeite plus quartz. Albite give rise to jadeite plus quartz at 200 degrees centigrade 7.5, 300 degrees centigrade 9.5 kilobar, and another reaction is your chloride plus albite give rise to glaucophene at 350 degrees centigrade 7 kilobar by Rover in 1972. Thus, we can suggest that temperature and pressure limit of green cyst phases is varies from 400 to 450 to 550 degrees centigrade from pressure from 4 to 8 kilobar.